So today we're gonna see the definition of a convex function. So in the previous video we saw in the last video what is a convex set, second video an exercise demonstration about if two sets are convex and the intersection of their sets are convex. And now we're gonna throw the definition of convex function. So a convex function, it's less or more the same prerequisites, like it's based on it. So let S be a convex set. We can see what it is in the first video. Then and having like f being a function going from this set into R, the ensemble R. Then we say that f is convex if so the same prerequisites, that for convex sets. Then it's f is convex if x and y being into S and lambda being into 0, 1. Like so f convex if so yeah, if for all x and y being into S and lambda being into 0, 1, we have the function of it, like the function of the definition of a convex set in a way. you know so you just put the like how different convex sets into the function, and so you have this is inferior to lambda f of x plus 1 minus lambda f of y. And that's the definition. And so we can try to go through our examples. So yeah, that's it because it's convex, and if it is strictly convex, then you put it like this, like strict inequality if strictly convex, and just an inequality not strict is convex function. So yeah, maybe we can say that also that yeah, we can say that the function f is said to be concave if minus f is convex. So it's like the opposite inequality. So that's convex, and in the other sense, it's concave. If you do not remember, bro, I cannot. I need to. Let's see. Convex. So concave is like this, and convex is like this. Wait, wait. And so, if you okay, d'accord. And so, if you have an example of hyphen function like this, it can be like this. This is a convex function. The norm is also a convex function. So that's two examples of convex function. If I write it correctly, we can write it like this. But in case it was not familiar, I wanted to, put it to a normal notation. So yeah. So if we let V be a real vector space, A between 2V and B into R, the hyphen function going from V to R is defined as this. So yeah. So it means, let's suppose we take, for example, for this example, 2x plus 3. It means that we would have like, if you take x, for example, like you need to take two example in this case. You need to take one x1, one x2, so it's more complicated. So I'll do examples in another video with this, because it's a little tricky to define the two things. And so if you take, for example, x1 here, or just x, is equal to yeah, you take, like, for example, x and y, like x being 1/2 and y also being 1/2. You can see that you can take, for example, it will give you here, and you take, I don't know, lambda being between 0 and 1, so we can take lambda 1/4, and so you have 1/4 by this plus 1/4, no, 3/4, because it's 1 minus lambda of this, and so, and you have, because it's a function, we say the function is this, so we put it like this, and so you'll have, it's equal to 1/8 plus 3/8, which is 1/2, because it's 4/8, and you can do the simplification. And here you'll have lambda of, so x. So that's not a proof, but it's an example to prove it works in this case. For example, plus 1 minus lambda of y, because f is just this, so you just apply the function. Now all of this represents this, and so it just give you one over 2 of x, 1 over 2 by 1 over 2, plus 1 plus, oh yeah, it's 1 over 4. We choose for lambda 1 over 4. So 1 over 4 plus 1, and here 3 over 4 by 1 over 2. And so it's same calculation in a way, so it's also equal to 1 over 2. And so we have here 1 over 2 being inferior to 1 over 2. And so, I mean, just an example, but you see it respects the definition of convexity. Well, it can also respect the definition of concavity, but you can find other example where it can define, it can goes like through convex, like always convex, but not every time concave. But we'll do exercises to more understand this. But what you need to remember is just this formula here. That's the main point, like this formula. The rest's not really important. So yeah, just have this formula and we'll do exercises in the next video.